Hello everyone, welcome to the channel Statistica Hub. So we were discussing about measure of central tendency. So out of that we have covered something regarding mean, and in lecture 2 we have read something about median. So somewhere mean failed, we know where did mean fail. So whenever there was some outlier, okay, when there is an outlier in the data, then the mean doesn't fit well. In a similar manner, the median failed somewhere. And where was that? Like if we have some clusters of data, clusters in the data, they will make our median absurd, mean to say meaningless. Then we introduce something regarding mode. So now let's see like what is a mode. So technically we have some data, and out of that data, the most frequently appearing value is the mode. Okay, so technically we have some data points. Okay, like this is a data point, this is a data point, this is a data point, and assume that this data point is like repeating for two times, three times, four times, this data for like two times, this data for like three times. Okay, so technically this data point is most popular, can say. So the data point that is most popular among the class of all the data sets, in that condition, this thing, this term or the data point is known as mode. Okay, now the point is like we can have for this particular format, like we have something over here that is some data points, okay, and we have some data regarding the age, okay, the age 1, 2, 3, 31, 32, 33. Like this is the data for our swimming classes, okay, the data from that classes. So we have like two clusters, okay, one is for the kids and one is for the parents, okay. Then out of these data points, like I have said something again, whenever there is cluster in the data, we go for like finding the mode. Okay, so mode mean to say the most popular term. Okay, so we have like two clusters, then we can go for like, we can't go for median. In that case, we go for our mode. So if I go for the mode, in that case, I can see like for the children group, we have mode as 2, because the maximum frequency for the age group 2 is maximum, that is 4. And in a similar format, for the age 32, the frequency is maximum among cluster 2, like this is the cluster 1, this is the cluster 2. So technically for any data, this data can be unimodal. Unimodal mean to say if the data has only single mode. uh, And we can have some bimodal data in this particular format, or in this particular case, we have seen like we have the data is 2. This is also the mode, and the value 32, that is also a mode. Okay, so these two terms like 2 and 32, these are having maximum frequency. So the simple meaning of mode is like mode is this is the data point with maximum frequency or the most appearing data in our complete data set. Okay, so that was like our initial introduction regarding mode. Now there is something more about mode, like the mode must be inside the data, like in the mean case and in the median case. We had some examples or some particular formats. In that case is like mean and median. These both can be inside the data, can be inside the data. That mean to say, if we see the data and we find the mean and median, this can appear in the data set, or this may not be in the data set. Okay, but for the mode is always inside the data set. Okay, this was like point one, and after that we can get some another point. That another point mean to say that this mode is an average for categorical data. What does that mean to say? Like for our categorical data, we can't go for mean and median, but we go for mode as a average term. Okay, so we have like 2 or 3 points regarding the mode. Like mode is the maximum frequency data. Okay, then mode must be inside the data. Great. And the third point mean to say is that mode is a average for categorical data. Categorical data mean to say, like, if I go for some example, that example states like, okay, let's go for like eye color. Okay, so technically we have different classes for eye color, like, okay, black, blue, green, and we can have some data from these classes. Then we go for like, okay, if this class is the maximum frequency, then we will say like, okay, this is the blue. So technically blue is the mode of this particular data set. Okay, so that was like initial understanding, like what is mode. Okay, now let's come to the basic example that we had regarding our clubbing, the health club. In the health club, we saw something regarding some swimming classes. For the swimming classes, I can see, like in the previous lecture, we have seen something regarding this, that is a histogram for our data. So for that data, we can see like, okay, then for this age group, that is for the age group 2, we can have a frequency of 4. So this is the maximum frequency. Okay. And for the age group 32, we have the maximum frequency. So we have like two modes. So this data is a bimodal because there are two modes. Great. Then this mean to say like we have two clusters. So technically for this particular case, we can't go for our median age. Okay. So we just cross median age and we can see the mode ages are 2 and 32. Great. So we understood like from this particular example, we can see like we have two different modes. So for any single, like if we don't have any cluster in the data, for that condition also we can find the mode, like for any data that is not having any cluster. Okay. So the frequency plot can be something like this. In that case, this is the like the maximum frequency. So this number will give us the mode. So in this case, this is unimodal. Okay, but for this particular case, I can see like if I make a histogram and if I make a rough curve, the curve can be going something like this. That means to say we have two different peaks for like two different clusters. So this particular case is bimodal case. Okay, now let's come to like categorical data. So we can have in categorical data, we can find the mode term because we can't go for like any numeric values in this categorical data. So we can't find our mean and median. Okay, these are like invalid for this particular case. That means to say the categorical data because we don't have any numeric values. Okay, so we go for our mode term. So technically mode is an average for our categorical data. So we can start it down and note down. Like for this particular example, we can see like, okay, we have different classes, some power workout, some kung fu classes, some little duckling, that means to say swimming classes. Okay, then we can see like, okay, the maximum number of frequency that is coming out to be like 18, and the 18 is the frequency for swimming classes. So the swim class is known as the mode class. Mode class is swimming. Okay, so for the categorical data, we can also find the mode. Great. Now let's come to the steps for finding the mode. So like it is very easy. Like we need to find like which data point is appearing for the maximum number of times. So we can find simple solution. That means to say first we all go for some distinct categories. Okay. For the categorical data, we make some different categories. Or if the data is some numeric data, then we go for distinct values in your data set. Like if 1, 1, 1, 2, 1, 3, 4, 5, 1, 2, and so on. So like in this particular data, this is first value, this is the second value, this is the third value, and we need to find the frequency for the data. Okay, so the first step is just find all the distinct categories for the values in your data set. Then in step 2, we go for write down the frequency for each value. Great. Then in step 3, we pick out the ones with the highest frequency to get the mode. Okay, so we have frequency f1, we have frequency f2, we have frequency f3, and so on. So if assume that if f2 is the maximum value, then the x value corresponding to f2, so technically x2, will be a mode. Okay, in case if I find f2 and f3 equal and f1 f2 and f3 are always greater than our any other fi, such that I is not equal to 2 or 3. In that condition, like these are the maximum values. So in this particular case, we can have x2 and x3 both as the modal terms. You can say the modes. In this case, this is bimodal. Okay, so like that was very easy part. Okay, so like when do you think like mode is most useful. Okay, think about that. Like there is mean, there is median, then there is mode. So the question is like mode is most useful in which cases? Okay, so let's come to this point. So like we have seen something regarding this, like categorical data. For the categorical data, we can't find our mean and median. Then there is only one kind of average, that is mode, that can be used for our categorical data. So like for this particular question that is stating that what is the most useful case for mode. Okay, so the first point that we can state is for categorical data. Okay, like for categorical data, we can't find the mean and median. In that case, mode is the perfect fit, perfect fit for the average. Okay. And second condition is if like for the data, if we have a few number of mode. Okay, what does this mean to say? Like if you have some data set, okay, if I assume like this is the data set, and if I find okay, this is the mode, this is the mode, this is the mode, then that is like fairly easy, like easy to see like okay, we have only three model terms. Okay, but if like if we have a data set and if find okay, this is the mode, 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 like we have many modes. Okay, in that condition I can't state like okay, this is a particular value that can be used for the average for the data. Okay, in that condition it fails. So technically, if we have less number of modes, in that condition we can use the mode as the average for the data. And for the categorical data, we can define only one kind of average, that mean to say the model term. Okay, so like that was our initial understanding regarding mode, like how do we find the mode, what is mode, and why it is most useful. Great. So like it is written over here in the vital statistics. That mean to say the mode has to be in the data set. Okay, it's the only average that works with categorical data. Great, we understood this concept like in the initial of this video. Okay, great. Let's come to our okay. Now we have like understanding all three at once. Okay, we got to know like what is mean. We know what is mean. We understand this thing. Then we understand like what is median. We understand that thing. Then we got like what is mode. We have the idea regarding this. Now let's see if I compare all these at once, what can be understood or what can be seen regarding them. Okay, great. So like we need to complete this table, okay? So we have different kind of averages, okay? We can have mean, we can have median, and we can have mode. Okay, now they need to find like how do we calculate this mean value? So we know like for finding the mean, we have some easy calculation, like we have some xi, we have some fi, or in simple form, if we can have only xi, in that condition we have summation xi divided by n. Okay, get that gives our mean. Great. And if the format is like this frequency table, in that condition the mu, that is mean, that will be equal to summation xi fi divided by summation fi. Okay, we got to know like how to calculate the mean. Then if we go to median, then like if we have any data set, we go for like arranging the data. Okay, arrange the data in ascending order. Okay, now the data points can be something n. If this n is odd or this n is even, so when n is odd, we can have okay only one singular point that is at the middle of the data. So that will be the median. Okay. In this case, we will have two middle values. So middle one, middle two, and we find the median to be like m1 plus m2 divided by 2. Okay. So generally this is a particular solution, but any point in between m1 and m2, that will be a median. Okay. Then if we go for the mode, then we have some data. Okay, we have some x data. We find the frequency for the data, and the x with maximum frequency is the mode value. Okay, we understood like how do we calculate these values. Okay, so when does we use mean? So when the data is fairly symmetric. Okay, so in that case, if the data is symmetric, in that case we go for like okay, this is the mean is the average, like mu average, and this mean can be used to generalization of the data set. That means to say like mean can be used as the like appropriate value for the like summarization of the data. Great. Now let's come to median. So we use median generally when there is some kind of skewness in the data, like when there is some skewness in the data. Okay. So whenever there is a skewness in the data, then we go for median. Like there can be some right-tailed or something left-tailed. Great. So like we go for median in these particular cases, and we know skewness arises due to outliers. Okay, great. Then we go for like model term. So when do we study regarding mode? So technically, first is like we have read this in this particular video. That means to say some categorical data. Like if we have categorical data, in that condition we go for mode as the average for the data, or whenever there is one or more, like two or more clusters. Okay, whenever there is clusters in the data, then also we go for mode, like the example of our swimming classes. Okay, for the children, then there was nothing. Then we go for parents. In that condition, we had clusters, and we go for like model terms. That was a bimodal case. Okay, that particular case. So like it was the initial, or can say the basic understanding regarding the averages, mean, median, and mode. Okay, so I hope I was fairly capable to get you an idea regarding mean, median, and mode in my these particular three videos, like lecture 1, lecture 2, and lecture 3. Okay, so that was the combination regarding like mean, median, and mode at once. Now let's take up some example to understand like how do we deal with this particular kind of problems. Okay, so like this is an example. Okay, the CEO of Starbucks Coffee wants to give all his employees some pay raise. Okay, so there was some initial pay. Great. Now the CEO decided to, okay, let's make up some hike in the pay for the employees. Okay, then he decided to give some hike, and in that condition, he had like two options. Okay, he was not sure whether to give everyone a straight $2,000 raise or whether to increase the salary by 10%. Great. So like this CEO, this person has like two options. Okay, so the option one states that he can give an initial rise of like $2,000 at once. Great. Then he decided to give the option two. That means to say like we have option one and option two. It is stating that okay, the increase by 10%. Okay, and it is given for this particular data. We have something regarding this. Okay, the initial conditions, like our mean that was given to be, we have mean of 50,000. Great. And then we had the median, like median. If I say median by M bar and mode by capital M. Okay, great. So the mode term is 10,000 and the median term is 20,000. Okay. Now what happens? We have like two options. Then we have to choose either option one or option B. Then let's go to like our questions. So what happens to the mean, median, and mode if everyone at Starbucks is given a 2000? Okay, if the CEO choose option one, then we need to find like how the mean, median, and mode will change. Okay, so we know like mean equal to summation xi divided by n. Great. Now that was like, so initially that value was like 50,000. Okay. Now there is an increase of 2000 for each value of xi. So that means to say summation xi plus 2000, like we have summation for every term, then divided by n. So that will be summation xi divided by n plus like this summation 2000 divided by n. Great. So this summation can be turned to be like 2000 into n, like we have n objects. This will be cancelled out. Okay, great. In that condition, that is 50,000 and this is 2000. That is 52,000. Okay, so we have seen like mean will change by this condition. Now let's come to the median value. So technically, when I am giving hike of like 2000 pay, in that condition, every term will be summed up by 2000. Okay, so the initial median was at like 20,000, like initial median that was 20,000. So the new median will be like if the median new, so that will be 22,000. Okay. Now, if I go for the mode term, so the mode term will remain to be like, if this is the maximum term, 10,000 is appearing for the maximum term, maximum number of times. And if we give a hike of 2,000, so that will be added to this term. So the mode term that will be coming out to be, if that is coming out to be the new value, so that will be like 12,000. Okay. So that was why the hike of 2,000 pair is. Okay. Now, if he choose the option B, so that means to say, like we will give a 10% hike. So technically, this was the 100% initially initial pay. If there was a hike of 10%, that means to say like 100 plus 10% total. Okay, so that means to say we will multiply all the values by 1.1. Okay, because that is the increment. Okay, So in that condition, this mu, that is the mean, that will be coming out to summation 1.1 into x divided by n. Okay, so we can write it to be like 1.1 summation xi divided by n. This is 50,000, the initial thing that is given to us. So 1.1 into 50,000. So when we calculate that part, this will be roughly coming out to be, okay, 5510,000. Okay, so if he give a hike of like $2,000, in that condition, the new mean will be coming out to be 52,000. If we give a hike of 10% pay raise, in that condition, the new mean will be coming out to 55,000. Great. Now, if I see for the median, so the median term will be also multiplied by that condition. So 1.1 into the initial median, that is 20,000. So if we calculate that thing, so that will be like 22,000. So like the median value will remain the same. Okay. If I go for the mode term, so the mode term will be getting multiplied by 1.1 into 10,000. So that is coming out to be 11,000. Okay. So that is coming out to be 11,000. So the new mode in that condition, I have written something wrong, I guess 12,000. Okay. Okay. So for option one, we have seen like mean will be coming out to be 52,000. And if I see the median term, that is same for both the cases. So I will ignore that part. Like that can't be used for like any manipulation or some kind of comparison. Okay. And the mode term that is coming out to be 12,000. Okay. If I choose option two, in that condition, the mean is coming out to be 55,000 and the mode term that is coming out to be 11,000. Okay. So that can be easily seen. Like if my wages were like mean wages, in that condition, I will be better off in case two, that is option two. Like this hike is better than this hike. Great. If my average was taken to be mode, in that condition, this option one is better for me because in this particular case, I will get a hike of 2,000, but in this case, I will get a hike of only 1,000. Okay. So like this is how the mean median mode can be used in the particular kind of business problems. So like in option C, that can say la correct. Sorry, the question C. In that condition, which sort of pay raise would you prefer if you were earning the mean wages? Okay, so my wage were like mean wage. In that condition, I will opt for option two. And what about if you were on the same wage as the mode? So in the case of mode, I will go for option one. Okay, so for this mean wage, we can opt option two, and for the mode wage, in that condition, we will opt for option one. Okay, so I hope this example was like some easy example and easy to understand and slightly understandable, like how things can be combined, how things can be compared, and how things generally affect in the cases of averages. So that was all about our measure of central tendency. In this particular video lectures, we have read something regarding mean, median, mode, and we have compared all these terms at once. I hope you got the basic idea regarding all the kind of central tendencies. That's all about central tendency. Thank you.